In our modern-day environment, fossil fuel and liquid gas have become an integral part of our daily lives. Modern technology has made these fuels and gases accessible to all mankind. But large production processes and rapid growth have brought with them the risk of fire and explosion, and the resulting loss of human life and material assets. Safety engineering and current legislation are often out of date. Statistics show us that the loss of lives and assets from explosions caused by fires or by fires caused by explosions are increasingly more common than other types of accidents. Recently, modern technology has led to the development of an effective system to completely eliminate the risk of explosions, a system that is available to all as a result of a revolutionary new product, xPloControl. xPloControl takes the form of a netting and balls that are used to protect vehicles in existing deposits. If we employ xPloControl in fuel deposits, the risk of explosions completely disappears, while on-site repairs can be made without having to remove the fuel and, of course, eliminating the bothersome and costly method of degasifying the deposits before repairs and saving on possible loss of fuel. xPloControl does not react with fuel. It is an ecological product that prevents leaked fuel from contaminating the environment or subterranean water. The enormous conductivity of aluminum prevents the formation of hot points. Explosions in fuel deposits take place when a large amount of energy is released in a very short time. This effect is the result of an exponential type chain reaction which almost instantaneously leads to the uncontrolled combustion. xPloControl mechanically regulates the reaction speed without altering the chemical properties of the fuel. Its hexagonal cells hold back with an onion layer effect the kinetic energy of the explosive advance of gas from the time of ignition. Apart from this kinetic effect, the netting provides extraordinary thermal conductivity that absorbs and distributes the calorific energy, preventing the formation of hot points. This prevents an initial chain reaction. The gas enclosed in the deposit is then removed from contact with the stoichiometric mixture, and since the air is rarefied, the danger of explosion disappears. Combustion is similar to a fuse effect, and gas can only ignite at filler necks or due to possible fissures produced by such accidents as impacts, excessive pressure, fatigue, etc. When the netting is employed in a deposit, the flames are insignificant. xPloControl is an aluminum alloy with which fuel tanks are filled, employing the principle of heat conductivity. This completely eliminates the danger inherent in tanks that store and transport fuel. When the netting is withdrawn, the proportions of the fire of a deposit which does not contain xPloControl can be seen. When the netting is put in the deposit again, the flames are controlled. Since xPloControl prevents the splashing of nearby deposits, the distance between storage tanks can be reduced, producing major savings in the design of storage installations. In vehicles protected by xPloControl, the risk of explosions produced by fire completely disappears. Overheating of the deposit that increases fuel tank pressure, bursting, and then producing the boiling liquid expanded vapor explosion. The risk of explosion produced by impacts or poor handling also disappears, since flames can be put out by simple manual techniques. Here we can see the safety that xPloControl confers on a 10,000-liter tank of petrol that is filled with burning fuel without any risk of explosion. The deposit is also protected by xPloControl. When the tank suffers from an accident, the flames will only emit from the crack produced by the impact. With xPloControl, the risk of explosion caused by a flechette or an igniter or tracer bullet will disappear. ExploControl prevents burst transfers of fuel, and the risk of destabilization of the vehicle transporting the fuel disappears. A tank protected with ExploControl must be correctly filled with the product. Loss in volume is only between 1 and 1.5%. A 100-liter deposit protected by ExploControl can contain 99 liters. Its weight is 0.33 grams per 10 protected liters. Here a test is made with 2 bottles of butane gas protected by ExploControl. When the pressure is increased inside the bottle, the gas is released through the safety valves. The fire darts freed by the bottles overheat the steel in non-refrigerated zones due to the effects of the now evaporated liquid. The aluminum material distributes the heat evenly, preventing hot points and possible explosions. The intense heat has deformed the bottles. Here are 2 bottles without ExploControl. Hot points are produced that weaken the metal. As a rift is produced in the bottle, the liquid butane is overheated, nucleates, and finally results in a boiling liquid expanded vapor explosion. Here we have a butane bottle with ExploControl in an extreme case. The safety valve is sealed off with steel bars that have been bolted down to its gas tap. When pressure is increased due to overheating, the soldering is affected and the gas escapes. The enormous heat generated by 20 liters of petrol and 25 liters of diesel oil increases the pressure yet again, producing the expulsion of the mixture, but not a boiling liquid expanded vapor explosion. Since the contact surface of the fuel inside the bottle with the aluminum is increased by 3,000%, thanks to the effect of the netting, the nucleating effect of the fuel is avoided, and thus a boiling liquid expanded vapor explosion. The crack, seal, and deformation of the bottle can be observed. This case is the same as the previous one, but without ExploControl. After 2 minutes, the bottle cracks. Part of the gas escapes that refrigerated the walls. The material is weakened. A crack is produced due to the enormous pressure, and the boiling liquid violently evaporates. Nucleation, and it comes into contact with oxygen, producing a boiling liquid expanded vapor explosion. Parts of the bottle could be found 200 meters away. The tray was completely destroyed. The energy freed in the violent explosion could completely destroy an apartment where the bottle was situated, together with 4 surrounding apartments. Shots made against bottles containing gas only produce a hole through which the gas escapes, making the valve itself a safety valve. The gas bottles are filled with ExploControl by a machine created for this effect through an existing orifice before placing the gas tap. Here we can see a chain reaction, explosion in a city gas pipe system. This accident could have been prevented with ExploControl, as we will now see. We are now accumulating gas. If an accident takes place in the pipe, The wave effect produced by the explosion would be transmitted only to the point where the protection has been set up. The flames are stopped at that point. We will see that upon igniting the opposite end of the pipe, an explosion takes place, refuting the theory that pipes don't explode. The reaction speed is exponential, making the pressure increase inside the city gas piping system in a short period of time, and then producing the explosion, in this case, the expulsion of the lid. Here we have a protection system that prevents the advance of the waves produced by gas combustion, avoiding the spread of fire from the protected zones and preventing a chain reaction throughout the pipe system down to the main tank, and thus avoiding an explosion. If an accident were to occur, we would only have to repair the stretch existing between two protective systems. Fields of application: gas tanks and developments, plants and butane gas bottles, refineries and chemical plants, aviation, military vehicles, aircraft and vessels, helicopters,
every motor-powered movement,
terrorism and public transport, vehicles and tanks, gas pipelines, oil tankers and fuel transport trains, etc. XploControl comes in netting that is placed in tanks and deposits during the manufacturing process, or as balls to protect existing fuel deposits. XploControl enhances structural sturdiness, allowing designers to replan the container structure, eliminating reinforcements and reducing production costs. Reticulated netting production machine for gas pipe protection. Machine for continuous netting production. Once the netting is produced, it is placed in this ball production machine. The process is continuous and a plant can work 24 hours a day with only 2 operators per shift. XploControl acts as a galvanic anode, preventing the oxidation of deposits. XploControl prevents the formation of algae. Insignificant volume loss. Fuel transport is made now extremely stable. The risks of accidental explosions is now gone, together with the repair of vehicles and tanks.